Good morning, scholars. Welcome to week 6, day 2. Today we're going to be still working on 7.12a, which is breaking down data sets. So taking it from a dot plot and matriculating it into a whisker and box plot. Yesterday y'all did fantastic. So I'm super proud of each and every one of you. If you have any questions, of course, reach out to me. So without further ado, let's go ahead and move on to day 2. So today, the questions are essentially now going to break down and hopefully help you to understand uniformability and knowing what a symmetrical graph will look like. So that's what we're going to work on today. Today's question number 4 states that the dot plots below show the weights of babies born at Hospital A and Hospital B during the month of January. The weights are rounded to the nearest half pound. So notice that your increments are by half pounds, okay? So that's going to play a very important role in this. Which statement correctly compares the shape of the data distribution on the dot plots? So your first step, as always, is always going to be, for this section, to just generalize differentiation, okay? So yesterday we did 5-number summary. For this specific one, it's not asking for that. It's asking for generalizations. So for this one, the number one thing I'm going to say to do to start off is just to be outlining your graphs. Okay, outlining your graphs is going to show us a general form of your graph, and it'll help a little bit easier with comparison. So as you can notice, I outlined graph A, and I outlined graph B. Okay, so it's just generalized outline. Okay. Your next step after you do so is you need to determine what side has a tail, if it has one, and is it only on one side, right? So remember that the definition for a tail is essentially the side of the graph where the data set has the lowest, has like a dip, okay? So for example, on A, we'll notice that we have a tail on the left. But notice that we also have a tail on the right. Okay, so we have somewhat of a tail on both sides. It doesn't just go up and keep data up, but instead it has a low point, reaches an apex at the very top, and then it comes down. Generally, because both sides are about the same height, I would say both sides have a tail, just for this graph. Graph B, on the other hand, if you notice, it has a low point, or it begins at a low point, reaches an apex, but it stays kind of high. So graph B on the other side would actually have a tail just on the left. Given that it's a tail on the left, we can already assume what this graph will be called. So the next question is it skewed right or left? Obviously, for graph A, I put it in question marks. Is it symmetrical? Well, you can generally say it's about symmetrical, okay? So symmetrical means that both sides have a tail. There's generally, it's what we call a bell-shaped curve. If you have any questions, go ahead and just Google bell-shaped curve and you can see it. But yeah, so graph A generally has a bell-shaped curve, somewhat, not really. It's not, textbook, but it's pretty much there. Graph B, on the other hand, this would be a skewed graph, right? And specifically, you name the skew by the side that the tail is on. So because this is a left tail, then this is also going to be called a left skewed graph. So left skew, low amounts of data sets on the bottom side, on the left side, okay? And then the last question you need to ask yourself, this isn't too common, but sometimes it does happen, is something called uniform. Okay, so uniform means, uniform means that the graph itself, the data sets, are a straight line. So generally, when it is uniform, it'll be just each data set will have like a set of 4. So it'll be 4 at 5, 4 at 5.5, 4 data at 6, 4 at 6.5, 4 at 7, so on and so forth, right? So it could be any amount, but it'll form a straight line, so there's no curve whatsoever. So in this context, hospital A is not uniform, and neither is B. Okay, so there's no uniformity. Yeah. So now that we've done this, now we can move on to our questions. So it says, which statement correctly compares the shape of the data distribution? The first one can't be it, because it says that the dot plot for both hospitals shows a symmetrical distribution of the data. So then, as I was stating, that the dot plots for both hospitals show symmetrical distribution. Obviously, we see that there's no symmetrical distribution for each graph. It's only for A, so that one's out. B says that the dot plots for both hospitals show a skewed distribution of data, one to the left and one to the right. So as we notice, that can't be possible because we only have a skewed left for the right one, and we have somewhat of a symmetrical distribution for the graph A. So that can't be B either. As we move on, we have C. The dot plot for A shows a general uniform distribution of data, but the dot plots for B shows a symmetrical distribution. So that's actually the opposite. So as you can see, A is the symmetrical graph and B is the uniform. So there's no way it could be C. So we go on to D. It says the dot plot for A shows a general symmetrical distribution, and for B it shows a skewed left. So yeah, that would be the one. So if I had to choose an answer choice for 4, I would pick D. That would just be D. Now we move on to 5. So for 5, we see that a teacher recorded the number of absences for 7th grade students in her class last year. The teacher summarized the data on the dot plot below. So it says, which box plot best represents the same data on the dot plot? So now we're moving back to what we learned yesterday. As you can notice, I still have class A already set up, but that's the information we're going to have to get to following all the steps we learned yesterday. Okay. So the first step, of course, is always to put your numbers in ascending order. So we practiced that yesterday. Once you put them in order, then you have to find your minimum, your maximum, your median. Those are the easy ones. So minimum is the smallest value, maximum the largest value. The median, you have to go one by one until you get to the middle. So you go one by one. Go through it quickly. Here we go. So you're going to cross one out, left, right, left, right, left, right, and then you're going to get to one in the middle. Okay. So now you can figure out that your minimum is 0, your maximum is 12, and the median value, we have a perfect median number, and the answer is 4. Okay. Next step is you're going to move on to step 4. So step 4 is to place parentheses. I personally put them, color-coded them. That way it's a little easier. So the left side of the information, I put it as one color, the right side is another color, and you'll see it here. So I colored it blue, and I colored it red. Notice that because I utilized 4 as my median number, it's black. That means I'm not going to use it. So when you have only one value as a median, key note, when you have only one value as a median, you do not use it in the separation to find quartiles. So in this case, I'm going to cross them out left and right, but I'm only going to use the numbers that are on the left and right side of my median value. So because I used the 4 in my data set, I don't use it for quartile 1 and for quartile 3. So I cross them out one by one. Crossing out, get to a middle value, and we'll notice that either way, I'm still going to get a middle value of 2. Okay. Same thing I do on the right hand side, cross out, cross out, cross out, and we'll notice that as we get closer, once again, even if I would have had 2 values, it still would have came out to 8. So I use this value for quartile 1. I use this value for quartile 3. And the last thing is to write your summary. So we've already written our summary. So now we have to construct the dot plot. Construct the box plot. So using these values, this is how you make a box plot. So the first thing is, for step 6, now that I've made my values, I essentially use those to create a number line. So for this one, notice that my number line goes from 0 to 12. So I'm going to give about 2 more values. I went from 0 to 14. So I have 0 to 14. And then I need to draw my straight line. But I'm going to draw that line using the points that I'm given. So my medium is 0. My minimum is 0. My quartile 1 is 2. My median is 4. Quartile 3 is at 8. And my maximum is at 12. Okay, so I put those values on my graph. Now, my quartile 1 and my quartile 3, I draw a box around them. I'm going to draw a line down the middle for my median. So that's quartile 1, median, quartile 3. And then I connect those with a line. And I've just created a box plot. So now your next step is just simply to pick the answer choice. So we go to A, we notice that we have a dotted 0. Then the next dot's at 2.5, so it can't be A. Go to C, we have our first dot at 0, second dot at 2, perfect. Next dot, median at 4, great. Then we have a quartile 3 at 8, and we have 1 at 12. Okay, so that's for C, so that might work. We go to B. B says minimum at 0, okay. Then we have a quartile 1 at 2, yeah, looks about right. But our median is at 6 in answer choice B, so that can't be it. Okay, so we go to D. We have a minimum at 0, good. Quartile 1 is at 1, that's wrong. So it has to be at 2. Okay, so it can't be D. So then that means that our only answer choice, which matched perfectly, is answer choice D. So there we go. So that's the way you do it. So this 5-number summary is one of the best things to know about a data set. It helps understand, helps break down, and helps to summarize information given. So instead of going through all the values that we had in step 1, with a 5-number summary, we can get a generalization about all the data that we have. Alright guys, so today's exit ticket, of course, is to complete questions 1, 2, and 3. Send me proof via text, email, Teams message, whatever you need to do. Ask for help if you need it. Make corrections if I prompt you to. Other than that, have a wonderful rest of your day. And today we're going to end with our quote. So our quote for the day is, hard work beats talent when talent doesn't work hard. So basically this means that if you give your 100%, I know you guys can be super successful. Keep in mind I'm always here if you need anything. And other than that, guys, have a fantastic day. I'll see you all at 8:30 for our online session. All right, guys. Love y'all.